we need to rewrite the complex number in trig form. And we have z sub 1 equals negative 3 plus 3i. We're not multiplying, so I don't really care which is our z sub 1 and which ones are z sub 2. Well, the first thing I need, in order to put it in trig form, we have to have r times cosine of theta plus I times sine of theta. So I need an r value, and I need a theta value. So let's find our r value first. Well, r is just going to equal the square root of our two components. Remember, we can rewrite negative 3 plus 3i is simply the point negative 3, 3. So we are going to have negative 3 squared plus 3, not to the ninth, squared, which is going to be 9 plus 9, which is going to equal the square root of 18, which we can simplify down to 3 square root of 2. Now to find our theta, we're going to first plot this. Well, this is negative 3, 3, so it'd be kind of up here. And if I created a triangle, the base of our triangle would be negative 3, and the height would be 3. Well, a quick reminder, using that triangle, we'd actually just find beta. Theta is going to be this big measure right here. Well, if we look at theta, theta has to be less than 180. So this problem really is 180 minus this angle. So moving forward, we'd solve for beta. Well, we'd have tangent of beta equals TOA is opposite over adjacent, or our y value over our x value, which would be tan inverse. So beta equals the tan inverse of negative 1, which actually equals negative 45 degrees. Well, that matches what I said. We had to do 180 minus that angle, and since it's negative, we know it's either 360 minus 45 or it's going to be 180 minus 45, but starting it off, I knew it had to be 180 minus that angle. So our theta is going to equal 180 minus that 45 degrees, which is actually going to give us that 135 degrees. So our value is 3 square root of 2, so it'd be 3 square root of 2 times the cosine of 135 degrees plus I times the sine of 135 degrees. The correct answer was D, so a majority of us did get it correct. Make sure if you made a mistake, you understand why. All right, I think the easiest way is draw your point and figure out what your degree should be. 135 degrees matches that. For those that picked A at 45 degrees would be right here. That wouldn't make any sense if you actually drew this picture. The other one was 315 degrees. That would have been straight down here, because 315 degrees would be over there. So that one didn't make sense. I'm sorry. Yeah, 315 was the other one that you guys chose. It was A, B, and D. D is the correct answer. All right, that being said, is there any questions on this particular thing? I do stress to people that take a long time taking tests, you better be able to do this really quickly. All right, the longer this takes you, the longer the test is going to be and the more mistakes you're going to make. There should be generally a simple problem that's plugging numbers in and getting values out. The biggest mistake you should make is maybe doing 360 minus 45 and actually coming up with this one. You really shouldn't come up with A because it was negative 45 degrees, so that should have told you had to be subtracting from something. All right, that being said, what questions do we have from the homework? Leo? 37. 37 says we have the points 0, 2, and we're supposed to convert rectangular coordinates of each point to the polar coordinate form. To convert to the polar coordinate form, generally speaking, we draw a triangle, we get our theta, and we get our r value. The problem is, on this guy, point 0.02 is right here. You can't make a triangle. In fact, if you take the tan inverse of 2 over 0, you're going to come up with undefined. Well, just a quick reminder that r equals your length of your line. So in this case, r is going to equal 2. The other thing I need is theta, where our theta is this measure here. Normally we need to use a triangle because that helps us actually get our theta, but in this case our theta is just 90 degrees. If we look at our unit circle, that is just 90 degrees. That is our pi over 2. So we don't have to use a triangle. We can just recognize, well, hey, that's 90 degrees. I have my r value, I have my theta value, so that's just going to be 2 comma 90 degrees would be its polar coordinates. All right, so some of those are just, you just have to draw it and kind of recognize what the degree measure is. So if it was 180 degrees, you once again couldn't use a triangle, so you just have to recognize that this is 180 degrees. This is 270 degrees, kind of thing. Does that make sense? Yeah. All right, good. Other questions? Yeah, Fritz. 53? So 53 says that we are given the point -2, -7. And we have to convert that to polar coordinates. So we are given -2, -7, and we have to put it into polar coordinates. Well, the first thing I'm going to do is I'm going to find my r value. My r value is going to be the square root of -2 squared plus -7 squared. And it does say round everything to the nearest tenth, so that means just plug in your calculator, and that should come out to about 7.3. All right, then the next thing I would do is I would go ahead and plot that point just to see about where it is. Well, -2, -7 might be somewhere down here, where if I create my triangle, the base is -2 and the height is -7. So I'd be finding my beta, whereas theta would be all of that. So if I'm looking at how big theta is all of that, so it's 180 plus whatever this little measure is. So the first thing you're going to do is you're going to do the tan inverse. I should probably say beta. Beta equals the tan inverse of that -7 over -2. Make sure I did everything right. Which is going to be about 74.1. And our theta is just going to equal 180 plus that 74.1. And that comes out to that, equals that 254.1 degrees. So that'll give me the point 7.3, 254.1 degrees. Okay? Other questions? Okay, and we're going to go over to today's lesson. Today's lesson, we're going to learn how to kind of plot equations in polar form, and then we're going to learn how to use our calculators to do that for us. So starting off, so graphing a polar equation is accomplished pretty much the same way you would as a rectangular equation. You plot your x and y points over, you plot a whole bunch of them until you get the shape of that given object. Usually we're looking for like parabolas, lines, absolute values, circles and such. So the same can be accomplished doing our polar coordinates. You're just going to plot a few points so you can see the general shape of it, and then you can connect the dots either with a circle, a curve, or a straight line. Well, they start off this table saying, okay, if my theta is 0 degrees, and my equation is r equals 5 cosine of theta, we're just going to plug that 0 degrees into our equation. So 5 times cosine of 0 degrees equals 5. So this is going to be the point 5, 0 degrees. Reminder. That for polar coordinates, it's always r, whatever angle you have. So then what we're going to do is we're going to go ahead and plot this point. We're going to plot the point 5, 0 degrees. Well, on here, each of these are going to count as 1. I'm not going to put 1, 2, 3, 4 because it kind of muddles up your graph a little bit. So we're just going to count out 5. 1, 2, 3, 4, 5. And we're going to go up 0 degrees. Well, that means we're not going to move. So that point right there, 1, 2, 3, 4, 5, right here is that point 5, 0 degrees. The next angle they look at is 30 degrees. So 30 degrees is my theta value. We plug 30 degrees into it. We come 5 times cosine of 30 degrees is about 4.4 degrees. Is yours an about symbol or is yours a congruent to symbol? It should be an about symbol. That should be like that. It's about 4.4, so that's the point 4.4, 30 degrees. So we go out 4.4. 4.4 is about here, and we go up to 30 degrees. So we'll put a point about there. So that is my point 4.4, 30 degrees. And then they did the next one. Your job is to fill out this entire table and graph all of those points. Then if you get done early, do the next one as well. So your goal right now is to plot all of those points, see what kind of shape that is, and then do the same thing for the next one. We'll come together and we'll look at what I got, or coordinates. All right, we're going to graph number that 120 degrees together. So if you did r equals 5 cosine theta, you'd come up with this one being negative 2.5. And so the point we're going to be plotting is negative 2.5, 120 degrees. Now watch the visuals. So we don't always draw this line. This is just to help you see what I'm thinking. So I'm going to go negative 2.5. So that's about here. And then we have to go in this direction 120 degrees. Well, each one of those little tick marks is 15 degrees. So we're going to come around, and this would be 90 degrees. This would be 105 degrees. This would be 120 degrees. So this point right here would be the point negative 2.5, 120 degrees. Remember, this is our starting point. A positive angle makes it go counterclockwise. A negative angle makes it go counterclockwise. A hint will be all of your points should be on this line or to the right. You should have no points over here. If you have any points over here, those are all wrong and you have to redo them. All right, all the points should be over here.